Hey everybody. So today we are talking about something new called electron configurations, okay? So this is something that is kind of a different process altogether, something totally new that could be a little confusing at first, but once you get down with the process, it's not that bad. So if you feel a little overwhelmed at the beginning, just stay strong and it'll all be okay in the long run, okay? So today we are talking about electron configurations, and forgive my handwriting, it gets better as the video goes on. Okay, so we're going through electron configurations. And what is an electron configuration? Okay, well, the electron configuration lays out how the electrons are in an atom. So it pretty much gives the layout of electrons in an atom. It tells us how the electrons are leveled by layer and in what orbitals. Remember, we have our s, p, d, and f orbitals, right? We got our sphere, we got our double dumbbell, or we got our dumbbell, sorry, we got our double dumbbell, and then for f, we got our flower. Okay. And, they have 1, 3, 5, and 7 orientations. Okay, so our electrons are laid out in this way and on these certain probability maps. So they go around their racetracks, right? Well, these electron configurations tell us how an atom, what kind of racetracks it has, and how many electrons it has in each racetrack. So let's do an example. Let's do chromium. Okay, chromium has an electron configuration of 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d4. And you guys might be saying, okay, what the heck is all this stuff? Well, this actually tells me how all the electrons are laid out in this chromium atom. And you might be seeing this and saying, how the heck did we get this? Well, we will get there in just a second. But first, I want to show you what this actually tells me. So if we look at a chromium atom, we got the nucleus here, right? It's got some protons and neutrons in there. We're not going to get specific about that because right now all we care about is the electrons. So each of these gives us a certain designation. So this guy has, in the first energy level, an s orbital, which looks like a sphere. Okay, so in the first energy level, s orbital with 2 electrons. Okay, so now that electron, part of the electron configuration is done. Now we have 2s2 in the second energy level, right, which is a little farther out, s orbital, which looks like a sphere, and it has 2 electrons. But also in that energy level, there are p orbitals. And remember, the p orbitals have 3 orientations. So we're in the second energy level. There's 1 p orientation. There's the second p orientation. And there's the third p orientation. And don't worry, you're not going to have to do this, but I want to show you what this is telling me. So in the second energy level, we got those 3 p orbitals, and each of them have an electron. Remember, each orbital gets 1 before we double up. So that's 2p6. Now it's time for 3s2, third energy level, s orbital, 2 electrons. Once again, 3p orbital. So we got 1 orientation, 2 orientations, and 3 orientations. And each of those have an electron. So there's our s orbitals and p orbitals. 4s2, remember? So we'll go all the way here. And now d, right? D orbitals. Those are those double dumbbells. And it's back down to the third energy level. So it gets crazy, right? Double dumbbell. So that's 1 orientation. That's 2 orientations. 3 orientations. 4 orientations. And remember, there's that one that looks like a donut that's in here. I'll draw that as well. And there's only 4 electrons, so only 4 of those orientations are going to get an electron somewhere in here. So as you can see, this gets pretty crazy with electrons and the paths they travel in these orbitals. Again, you're not going to have to do this, but I just want to show you what this electron configuration is showing us. So let's go ahead and let's figure out how to do these electron configurations. So first things first, we got to lay out our periodic table a certain way. First thing we do is we take our helium and we move it over here. All right. And the next thing you need to know is that we chunk off this periodic table into certain sections. Okay. This first section right here, these first 2 tall columns, right? These are our s orbitals. All right. Over here on the right, this nice big block of 6 by 6 are our p orbitals. Right here in the middle, all these transition metals in this big long rectangle, these are our d orbitals. And then down here, this lanthanide and actinide series are our f orbitals. Okay, so we don't start getting into p orbitals until we get into these elements, d's until we get into these, and f's until we get into these orbitals. So let me go back to my black color, and we are starting at hydrogen, and we read this as a book. So what we'll do is we'll go ahead, we'll start at hydrogen, and we'll move all our way through down like reading lines in a book, depending on what element we go for. But let's make this easy and start with hydrogen. Now, as we go down the periodic table, each row signifies a certain energy level. So the farther down we get, the higher energy levels of electrons we get. But say we're starting with hydrogen, okay? For the electron configuration for hydrogen, we state what energy level it's in, which is what row it's in, which is 1. We state what orbital we're in right now, which is the s orbital. And then that exponent right there just tells me what element that what number that element is in that row. So in this first row, it is the first element. So hydrogen's electron configuration is 1s1. Okay, first energy level, s orbital, first one in that row. So let's look at helium. Okay, helium is the first row, s orbital, and it is no longer the first atom in that row, it is the second. So it is 1s2. So you have now given the electron configuration for hydrogen, which is 1s1, and helium, which is 1s2. Okay, and as we go farther down the periodic table, they get a little bit more complicated. Now this is like an orbital jurisdiction. Okay, we do a new one each time we hit a new energy level or we hit a new orbital. And I'll show you what I mean here in just a second. So let me erase this. Let's focus on carbon. Okay, so we are looking at carbon right now. And again, if we're going here, we got to list all the electrons that came before it. Okay, so once again, we are starting at the beginning and we're reading these like lines in a book. So we got to get through this whole row first. Okay, so in order to get through this row, I say that first energy level, s orbitals. And to get through these two, I got to go 1, 2. So to get through this, I got to say 2. So now I've gone through the first row, and now I'm in the second row. Well, now that I'm in a new energy level, I got to start a new electron configuration, which is now I'm in the second energy level. I am in the s orbital still. And remember, I'm trying to get to this carbon over here. So I got to say 2s2. Right now I'm moving my way back over to here again. Now I'm in a new orbital, so I got to state the energy level again, which is 2. Now I'm in the p orbital, and to get to carbon, it is 1, 2 to get to that. So we did 1s2, 2s2, 2p2 to get to carbon. Okay, let's go ahead and let's do another one. Let's go ahead and do neon. Let me undo until I clear everything. Okay, now we are doing neon. All right. So again, we're starting from the beginning. We got to get through our first row, which is 1s2, right? First energy level, s orbital, 2. Got through that. Now we're in the second energy level, right? So 2 still in the s orbital. Got to get through it. 1, 2. Now we are into the p orbital. Again, we're still in the second energy level. We are now in the p orbital. And 1, 2, 3, 4, 5, 6, right? As you can kind of notice is that the p orbitals have a max of 6. The s orbitals have a max of 2, right? These are their sublevel electrons. So d would have a max of 10, and f would have a max of 14. Okay, so that is neon's electron configuration. Let's go down to calcium and see what we can do there. Okay, so I'm going to get rid of this one. And we're going to focus on calcium now. I hope I erased my helium. Silly me. All right, calcium now, right? Once again, we start all the way from the beginning. So go through this, and it's 1s2. Remember, we're focusing on calcium. 1s2. 2s2. Going on down like reading lines in a book. Again, 2. We are now in the p orbital. 1, 2, 3, 4, 5, 6. Got to get through all those, right? Because now we got to get down to the next energy level, which is now the third. S orbital. 2. 3s2. Now we're into the p orbital, which is 3p6. And now we're in the fourth energy level, S and 2 to get to calcium. So now we're at 4s2. And that is the electron configuration for calcium. Now, you guys are probably thinking, okay, so then when we get to this d orbital, it'll go ahead and it'll be 4d10, okay? Incorrect. If you remember, when I was down here, I did 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4, okay? What happens here is that this, when we start in this d orbital, it now becomes 3. So it'll be 4s2, 3d10, and then when we come back out, it'll once again be 4p6. Then 5s2, 4d10, 5p6, okay? The reason being, right, it's just a lot easier for the atom to go up an extra energy level and fill these 2 s orbitals out, okay? It fills these 2 s orbitals out real quick, and then it says, okay, now I'm going to go back down to that lower energy level, and now I'll try to fill these whole 10 electrons, okay? So atoms like to do the easiest things first. They're kind of lazy like that. So they'll go to the higher energy level, fill those 2 electrons out, then come back down and do all the work of filling in those 10 electrons in that lower energy level. So let's go ahead and do iron real fast, just to get an example of that, and then we will move on to another example. So we got iron. Start from the beginning. We got 1s2. We got 2s2. We got 2p6. We got 3s2. We got 3p6. We got 4s2. And remember, now that we're in that d orbital, it's not 4d10, it is 3d, and then 1, 2, 3, 4, 5, 6. 3d6. Okay, so again, remember that when you get to the d orbital, it now becomes 3 again. All right. Now let's go ahead and let's do another example but this time we're going to go a little bit lower to number 56, which is barium. Okay, I'm going to bury you in electron configurations. Haha, haha. Okay. All right, so anyway, here we go. So we're to barium. So 1s2, right? We're going all the way down here. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Going down here now because I'm in our room. We're here now, right? So it's 3d10. Okay. Pop out on the other side. Now it's back to that fourth energy level, 4p6. Down here, it should be 5s orbital 2. Back into the d orbital again. We got to go down a level, 4d10. Back out, back into the fifth energy level, 5p6. And then, last but not least, 6s2. Okay, so that is the electron configuration for barium. Hopefully this is catching on for you guys. Hopefully you're seeing how this works. Again, this is telling us the layout of all those electrons. But now let's go into this territory. Let's go into our F. So as soon as we get into the 6s2 territory, remember this lanthanide and actinide series is actually inserted right here. Okay, they just take it out because if they had that in there, then the electron or the periodic table would be extremely long. So they take it out and stick it down here. So actually, when you go 6s2, you're going to pop on down here, okay? But then when you go 6s2, this now becomes the fourth energy level. So we were at sixth energy level, and we pop all the way back down to the fourth energy level to fill out this F orbital. And as you can imagine, right, it's probably got 14 electrons in there, okay? 14, because that's how many sublevel electrons we have. So I'm going to go ahead and I'm going to use this nice orange. So black will signify the beginning and orange will signify the end of the Fs. So what we end up doing is we go 6s2, we pop into this table and do 4f14, and then when we're done with the lanthanide series, we pop back up into here and go back to 5d10. Then 6p6, 7s2, pop back into this actinide series, 5f14, 6d, 1, 2, 3, 4, 5, 6, 7, to meitnerium. All right, so that's as difficult as it gets. Let's go ahead and let's do the all-famous uranium, and then we'll be done with electron configurations, at least the long version. And I got one more thing to show you after that that'll make your life a lot easier. So uranium, let's get going. Okay, so we're starting all the way at the beginning now, remember. So it is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. We're in the Ds now, so it's the third energy level, 3d10. Back out into the fourth energy level of 4p6. Back down to 5s2. Again to the Ds, so it's 4d10. Back out to 5p6. Down here to 6s2, and now this is where we pop on down to our lanthanide series. Remember, this guy's in here, right? So now it's 6s2, now it's 4f. We got to get all the way through 14. 4f14, and then we're at the end, so we pop back in to the main table, and we go 5d10, 6p6, 7s2, And now we pop back down to our actinide series, and it's 5F1, 2, 3, 5F3. Okay, that's as complicated as it gets for electron configurations. Okay, hopefully that made sense. And now let me show you a shortcut. Okay, right? Chemists got tired of writing out these extremely long electron configurations, so they went ahead and they devised a shortcut, okay, which are called the noble gas configurations. Now, if I tell you to do a noble gas configuration, you can do it. But for the most of the time, if I say do an electron configuration, I mean do the full version. Okay, I'll tell you when to do a noble gas configuration. So let's focus on our guy, sulfur. Say I don't want to write 1s2, 2s2, 2p6, 3s2, 3p4. What I can do is I can use the noble gas configuration. So these are your noble gases. Okay, those are the guys that don't react with anything. Okay, they're noble. All these guys: helium, neon, argon, krypton, xenon, and radon. So what you can do is if you want to give the noble gas configuration for sulfur, what you do is you go up a row, pick the element or the noble gas that is in the row above your element, which is neon, and you put that in square brackets, put the atomic number in the upper right, and now you can start from this noble gas instead. So again, it was sulfur. I went up a row. I picked the noble gas in that row, and now that's my new starting point. So I've pretty much gone through all of these without listing them. And then I could say, I'm going to start right here and go 3s2, 3p4. Okay. So that is the shortcut. And you might be saying, Mr. Dahmer, that's not really a shortcut. But when you get down to these guys, it becomes super helpful. So let's do platinum. Okay, the noble gas configuration for platinum. So what I do is I go up a row, and the noble gas in that row is xenon. So now my new starting point is xenon, warrior princess. Okay, so I'm right here. Right? So now I don't have to do any of those electron configurations from before. I'm just starting at xenon. So now it is going to be 6s2. Remember, I have to pop down here, 4f14. After 4f14, I pop back into here, and it's going to be 5d, 1, 2, 3, 4, 5, 6, 7, 8. 5d8. That makes things so much easier, doesn't it? Okay. The last thing I just want to say is that, say I am going with uranium, remember that these two rows are actually in here. So uranium is actually in this row down here, right? If we plug this guy into this little space right here and kick everything over, uranium would actually be in this bottom row. So if uranium was down here, its noble gas that I would use would be radon with a 86 above it, right? So again, it's in here. I'm now starting at radon. So now I could just go 7s2 and 5f3. So guys, that is electron configurations. If you are confused, please let me know and make sure you are asking questions. Know your shortcuts, know the long version, and have yourself a great day.